So here is the Module 4 Topic 2 review for the test on Tuesday. So here we go. So first question is describe the function, or given the function, describe the transformations. Okay, so we have, let's put that up there. We have three transformations. We have 1, 2, and 3. Okay, so the first one is, this is a reflection. What's an N? Over the x-axis. Number 2 is a horizontal compression. By 3. And number 3 is a vertical shift going up by 2. Okay, and number 2, same idea. Again, we have 3 different transformations. We have 1, 2, 3. The first one, this is a vertical compression. Oh, I spelled that wrong. There we go. Vertical compression. By 1/2. On 2, this is a horizontal shift to the right by 90 degrees. And number 3 is a vertical shift down by 6. All right. So this, we're given a periodic function. We want to find out this information. Okay, determine the period of function. So if we start the function, let's find for this particular function, and start at a high point. Okay, that's an easy way to find it. It's not trying to find the middle part. So if we're going to go down and back up to the next high point, how far away is it from here to here? And it is from 1 to 7, which is 6. Okay. Determine the maximum value. So the max, let's change colors for some of these things. So the max is the peak, which is going to be at 1. The minimum is going to be at down here, the valley of -5. Okay, determine the amplitude. So there's 2 ways to do this. You can either find the midline and then go from the midline to the top or the midline to the bottom, or you can find the total distance between the peak and the valley and then divide by 2. Either way, it would give you the same answer. So from 1 to -5 is going to be 6 total as a height. Divide that by 2, and the amplitude will be 3. Now the midline, since the amplitude is 3, if you go down 3 from the peak or up 3 from the valley, that's going to give you the middle of your graph. So I'm going to draw it as a dotted line here. And that's going to be y equals -2. Let's go back to blue. Okay, and those are the values for your periodic graph. Let's try this again. Okay, again, I'm going to go from the valley here, the lowest point, go up, and then down to where our graph is going to start to repeat itself. So my period is going to be 5. Okay, determine the maximum value. So the peak is at 5. The valley is at 1. So the amplitude is the distance between the peak and the valley divided by 2, and that is going to be 4 divided by 2, which is 2. Okay, and then determine the midline. The midline is halfway of the graph. Which we're going to draw right here, which is going to be y equals 3. Okay, next we got some work problems. Okay, so working alone Adam, we got Adam and we have Dan. So we have Adam. Let's do this. Adam and Dan. And they are harvesting over time. So Adam can harvest one field in 16 hours. Dan can harvest the same field in 13 hours. How long would it take them if they work together? So if they did one field, how long would it take them? So again, we're going to draw this little chart here. So we have 16, 13, and x. We're going to find the common denominators. So 16 is missing both 13 and x. 13 is missing 16 in x. And x is missing 16 times 13, which is 208. So we're going to multiply these numerators of 1, 1, and 1 by what our common denominator is supposed to be. So we have 13x here. I'm going to make it a different color so it's obvious. So we have 13x, we have 16x, and we have 208. So we multiply that out. We're going to have 13x plus 16x equals 208. If we add 13 and 16 together, we'll get 29. Now if we divide by 29, x will equal 208 divided by 29 is 7.17. Okay, let's change it back to blue. Okay, next kind of problem. Amy, we have Amy and we have Ted. Okay, Amy can do a job, so we'll just do job and time. Amy can do one job in 4 hours. Working together, all right, Amy and Ted can complete 3 jobs in 8 hours. How long would it take Ted to do 2 jobs working alone? So that's our equation set up. Okay, so again, just like before, I'm going to make this little chart to find our common denominator. Okay, so to get 8, I'm going to multiply 4 by 2, and it's also missing the x. All right, x is missing 8, and 8 is a number that 4 can go into. You don't need to multiply 8 by a number. You just need to multiply it by x. So now our common denominator would be 8x. So let's change colors again, and I'll show you how that works over here. So you're going to multiply the numerators by what was missing in the common denominator. So this is going to be 2x. It's going to be 8, and this is just going to be x. So we have 2x plus 16 equals 3x. Okay, if we subtract 2x from both sides, we're going to get 16 equals x, and that is our answer, because x is now by itself. All right, go back to blue. All right, and then lastly for the work problems, we have Jenny, we have Susie. We're painting fences in hours. So Jenny can paint 3 fences in 4 hours. Susie can paint 2 fences in 5 hours. All right, if they work together, how many hours would it take to paint 8 fences? So again, we have our little chart. Okay, so the 4 is missing a 5 and an x. The 5 is missing 4 and an x. And the x is missing 20, 4 times 5. Let's go back to red. So we're multiplying our common denominator missing pieces by our numerator. So we have 5x, we have 4x, and we have 20. So our let's do that. So we have 15x plus 8x equals 160. Okay, adding 15 plus 8 will give us 23x. And if we divide both sides by 23, x will equal 160 divided by 23 is 6.96. There we go. All right. Next, the other type of equations. Okay, we have 4 more problems to go. All right. So the first one is a radical equation. Okay. First thing you have to do in these kind of questions is get the square root part of the equation by itself, all alone. So to do that, we have to subtract 8 first. So 20 minus 8 is 12 equals 2 times the square root of x minus 3. Now, it looks like the square root sign is by itself, but it's not. It's got this 2 on the front of it. So we're going to divide both sides by 2 because that 2 is being multiplied by the square root sign. So we have the square root of x minus 3 is equal to 6. Now the square root sign is by itself. So we're going to square it. Okay, when we do that, the square root and the square root will go away. We'll be left with x minus 3. And then 6 squared is going to be 36. We add 3 to both sides, and x will equal 33. Or, sorry, 39. Now what you have to do is check this answer to make sure it works. So if you put 39 in for x, you get 39 minus 3, which is 36. The square root of 36 is 6. 6 times 2 is 12, and 12 plus 8 is 20. So that checks out, and that works. I'm going to go back to blue. I don't like red during most of it. Okay. For part B, same idea. Now this time the square root sign is by itself. So we're going to square both sides of this. Okay, and when we square the other side, we're going to multiply x plus 1 times itself. So the square root and the square root will go away, so you have x plus 3. On the right side, you have to distribute x plus 1 times itself, so you're going to get x squared plus x plus 1. Okay, now we're going to get all the terms on one side. Instead of taking the x squared and moving it to the left, I'm going to move the x plus 3 to the right. So I'm going to subtract x and subtract 3. So I'll end up with x squared plus x minus 2 equals 0. Now I can factor this. So I have x and x. What number multiplies to be negative 2 and adds up to be positive 1? And that is going to be positive 2 times negative 1. So I solve both these for x, and I'm going to get x equals negative 2 and 1. And now again, I have to check these answers to make sure they work. If I put negative 2 into my equation, negative 2 plus 3 is positive 1. The square root of 1 is 1. So I get 1 on the left, and then on the right-hand side, negative 2 plus 1 is negative 1. Well, 1 does not equal negative 1, and that does not work. Okay, now I put 1 in there. 1 plus 3 is 4. The square root of 4 is 2. On the other side, 1 plus 1 is 2, and 2 does equal 2, so this is my answer. The only one that works. All right, last two. Similar to our work problems from before, we've got to find a common denominator. So let's make our little chart here on the right-hand side here. So we've got 2n, we have 8n, and we have 1. I'm going to figure out what's missing. So 2n needs a 4 to make it look like 8n. 8n doesn't need anything, so we're going to actually multiply it by 1 because it doesn't change the value of our equations. And then the 1 needs to be multiplied by 8 and n. Okay, so we're going to have 4 here, 1, and 8n. So 4 times n is 4n. 4 times negative 2 is negative 8. Plus, if you multiply 3n minus 18 times 1, you're going to get 3n minus 18. And that equals 8n. 1 times 8n. So now all of our denominators will go away, and we have our equation right here. So what I'm going to do is I'm going to subtract 4n and 3n from the left-hand side and bring them over to the right-hand side. Okay, so those will cancel out. So I'll be left with negative 8 and negative 18 on the left-hand side. So 8 and 18 combined to give you negative 26. And then 8 minus 4 minus 3 is going to be just n, because it's 8 minus 7. So there we go. There's our equation. Now, one thing we do have to check is make sure that our answers work. If you took the denominators, 2n, and set it equal to 0, and 8n, and set it equal to 0, to solve what n cannot be 0. And since negative 26 is not 0, that works. In part D, same idea. We have our denominators. We have 2, we have x, and we have x. So 2 needs an x, the x needs a 2, the other x needs a 2, and that's what we're going to multiply by our top. So x, 2, and 2. So now our common denominator is set. So we have 5x squared plus 2x plus 2 equals 12x plus 2. So next, we're going to get all the terms on one side. I'm going to subtract 12x and subtract 2. So that will go away. So I get 5x squared minus 10x. And then 2 and negative 2 cancel out, so I'll just equal to 0. So with this quadratic, we can we can factor out a greatest common factor of 5x. And then we have x minus 2 left over. And now we take each of the factors, 5x and x minus 2, and set them equal to 0. So x will equal 0 and 2. Okay, again, we have to check our denominators. We have x, and x is the same, cannot equal 0. So this one, x equaling 0, does not work. The only answer that will work to solve this equation will be 2. Okay, so you've got to check which numbers can't work in your denominator. All right, and that brings us to the end of the review. Good luck on the test tomorrow.